Hello everyone, welcome back to my channel, day 3 of Python learning series. Today we are going to learn about flowcharts and algorithms. What are the flowcharts, how we are going to write algorithms, and what is pseudocode and time complexity and space complexity. So let's get into the topic. First one is the flowchart. In simple words, a flowchart is like a map for a task. It shows that what to do first, what happens next, and what choices or decisions come along the way step by step. So as you can see on the screen the example of the flowcharts. So this flowchart shows a simple daily routine in the order most people follow. You start your day by waking up, then brushing your teeth and take a shower to get fresh. After that, you eat breakfast to get some energy. Once you are ready, you begin your work or studies. After working for some time, you take a short break to relax. Then you continue your work or study until everything is done. Finally, you end up your day and get ready to reset. It's just a step by step way to show how a regular day usually goes. Coming to the symbols in the flowchart, as you can see the definition on the screen, flowchart symbols are simple shapes used to represent different types of steps or actions in a process. Each shape has a meaning and together they help you understand how a task flows from start to finish. So let's break this up like a funny story. First one is the terminer. It is in the oval shape. It is used to start or end. Think of this like a beginning or end of a story. You use the oval shape to show where the process starts, like waking up in the morning, and where it ends, like going to the bed. It says like here what everything begins, and that's it, we are done. Second one is process. It uses the rectangle symbol. It is used for an action or step. This is the main character in your story. Every time you do something like eating breakfast or writing code, you use a rectangle. It answers the question, what do I do at this point? Next one is the decision. It is an diamond symbol or you can say it as an rhombus. It is used like yes or no questions or choices. The diamond is where choices happen. Imagine you are deciding should I take a break. If yes, you go on one way. If no, you continue on. This shape helps branches of flow based on the decisions. Next one is input and output. It uses the parallelogram symbol. It is used to getting information or showing result. Think of this as asking or giving something. For example, typing your name as an input or printing a result as an output. It is used when you are taking in data and sharing data. Arrow is used to show the directions of the flow. This is a simple one, but it shows the path. Arrow connect all the shapes and show which step comes next, like saying go here next. Let's solve a problem related to the flowchart. So let's walk through this flowchart together. It's a fun and simple one that calculates the area of rectangle. So here, let's say we are asking to find the area of rectangle and we want to show the steps using a flowchart. First we will begin with the start symbol, which simplifies tell us where the process begins. After that we move to the next step. We need to input the values of length and breadth. This step is shown using the input and output symbols because we are using the information to the program. Once we have both the length and breadth, the next step is to calculate the area by multiplying them. Like area is equals to length into breadth. This is done using the process symbol, which is used anytime the computer performs an action or calculation. After the area is calculated, we need to show or print the result again. This is an input and output step since the computer is now giving us the result back. Finally, we reach the stop symbol which tells us the process is complete. So in simple words, the flowchart shows how to solve the area of rectangle step by step. Starting and taking input, calculating, showing the answer and ending. All laid out in a clear and logical order using symbols. It's like turning a math problem into a little story the computer can follow. Coming to the algorithms are very important topic. You can see the definition on the screen, like it is a step by step set of instructions to solve a problem. It is like a recipe that tells you exactly what to do in what order to get the right result. So let's understand it like we are solving a problem. Imagine you are asked to make a cup of tea. You don't just throw everything into a cup randomly, right? You just follow some steps, like first you boil water, then add tea leaves, pour it into a cup, maybe add milk or sugar, and finally stir and serve. These steps in the correct order are your algorithm for making tea. Now let's apply the same idea to the math problem, like finding the area of rectangle, like as we did before. Here, how we did think about it as an algorithm. First, begin the process. Take input, ask the user for the input, length and breadth. Do the calculation, multiply the length and breadth. Show the result, display the area. Next, end, finish the process. So each step is clear, specific, and in order. That's exactly what an algorithm is, a clear list of actions that solve a problem one step at a time. So, in simple words, an algorithm is how you break down a problem into small steps that a person or a computer can follow. It's just like solving a puzzle or cooking a recipe or explaining how to tie your shoes. So, algorithm needs the problem solving techniques. So, algorithm is a very important topic in Python or any other languages. So let's take one more example to understand the algorithms more better. So let's take we want to find the sum of two numbers. Let's think of this as in a little instruction list we are giving to the computer, so it knows exactly what to do, like a recipe for math. So here the first step is start. This is where everything begins. It's like saying, hey computer, get ready, we are about to do something. So step 2 is declaring three variables A, B, C. Now we tell the computer we need three boxes to store numbers. Call them A, B and C. Here A and B will hold the two numbers we want to add and C will store the answer. Step 3 is define values of A and B. So, time to give A and B some value. Let's say A equals to 5 or B equals to say 7. It might be anything. The computer know what numbers it's working with. Now, the step 4, do the sum A plus B. Now the computer performs the actual addition. It adds the number of A and B. So we have given 5 and 7. 5 plus 7 equals to 12. In the step 5, store the result in the C. The result of the sum equals to 12 is saved in the variable C. So C equals to 12, just like storing your result in a safe place. Next, the sixth step is print C. Now the computer shows us the result. It prints the value of C, which is 12. Now the last step, seventh step is stop. That's it. The computer ends the process. So here the algorithm follows the simple steps, like first give them the numbers, then tell them how to add, where to put the answer, and finally to say the result out loud. Easy, clear, and it is step by step. Pseudocode is way to write the steps of a program using plain and simple language like English. Pseudocode is also contains code, but it is not actual syntax. That looks like a bit real code but is not specific programming language. So let's take an example just before we discussed about the addition of two numbers. So here first we say that start, then we just tell the computer, hey, we are beginning our task. Then we say declare three variables. This is like telling the computer we'll need the three boxes to hold the numbers, as like just before we did. Next, we give the values, set A equals to 5, set B equals to 7, and you can give whatever the number you want to give. These are the numbers we want to add. Then we say set C equals to A plus B. This means then we are telling the computer to add the A and B and store the answer in the C. After that, print C. The computer will now show the result to us. Finally, we say stop. Our task is done. Like pseudocode is writing the instructions to a computer in a way that human can easily read and without worrying about exact code rules. Here, it helps you think clearly before coding. Time complexity and space complexity. Those are the very two important topics. Time complexity tells us how much time a program or an algorithm will take to finish as the input grows bigger. Based on the input, the time complexity depends. What is the space complexity? Space complexity tells us how much memory or a space a program needs to complete its task depending on the input size. So let's take a real time example for time and space complexity. Imagine you have a list of names on a paper and the list contains certain names like Priya, Sarah, John, and the list grows on. Time complexity, let's say you are trying to find Sarah in that list. If the list is short, like 5 names, you'll find it quickly. If the list is having 1000 names long, it will take more time. So, time complexity tells us as the number of names grows, how much longer will it take to find the one we are looking for. If you check one name at a time for the top, that's called order of n time because in the worst case you might have a look at every name once. Coming to the space complexity, now imagine you are writing the names down in the notebooks to search through them. Like if you only write names as you check them, you see very little space. But if you copy the entire list and store the extra details, you use more space. So space complexity is about how much extra memory do we need to solve the problem. If you don't need to store anything extra, it's called order of one space, just like a constant amount. In a simple words, the time complexity is asking how long will take as the work gets bigger. Here, the space complexity is like how much memory will I need as the data grows. In these complexities, we will have the best case, worst case, and normal case. Here, order of 1, order of n, and order of log n. We'll discuss this about later. Today we have learned the important topics like flowcharts, algorithms, pseudocode, time and space complexity. Don't confuse between the flowcharts, algorithms and pseudocode. Flowchart is used to represent the process in a diagrammatic way using the symbols. Here the algorithms are used to write the step-by-step procedure in a ordered format. The pseudocode is like a rough work we write before writing the actual code for the better understand. And time and space complexity, as we discussed, the time is for calculating the time for completing a program, and the space complexity is how much space we need to complete a program. That's all about today's session. If you have any doubts, let me know in the comment section.